And welcome back to my channel and part 5 of the spiral lamp. Titled My Software. This is just a quick and dirty run through of the software that I wrote to exercise the LEDs so that I could see if it was working and I was happy with it, and then maybe after that I'll move on to Well, let's start the software somewhere. So I'm going to start with the config.h, and here I'm going to put the things that I know that I might want to know about the spiral display. So starting off, out the ESP8266, I'm going to be driving pin 13, so I need to shift pin 13 into the data pin, and to do that you put in a 1 and then you left shift it by the GPIO number, and this number is defined in GPIO.h. Next we go on to, we want to know how many LEDs there are. Well, in the entire string there's 162, and so 81 LEDs in each string, and so because we start at 0, 80 becomes 81, so string 1 starts at 0, ends at 80. String 2 starts at 81 and ends at 161, so that gives us the two strings in the array. It's a sequential array. And then I want to know the midpoints, and so the midpoint of string 1 is just the end, 80, divided by 2, which gives us 40. I can't have the full midpoint because that'll be 40.5, so we'll just go for 40. And it's the same with the start in the middle of the string 2. We start with the start of string 2, which is 81. We take 1 off it, which is 80. We divide it by 2, so it's 40. We take 40 away from string 1, and that gives us a starting point 40 in from the top. So they're not quite matched. One's 40 up from the bottom, one's 40 in from the top. But I'm not going to argue with that. And then we want, like, when we're working with the strings, are we going to work with string 1, string 2, or both? So we just set the enumeration, so I can call them that and use the numbers. And the same for up and down. I enumerate up and down to be 1 and 2 respectively. And then we go on to the actual RGB structure. Well, these are RGBWs, so they're 32 bits in a data string, and they consist of 8 white bits, 8 blue bits, 8 red bits, 8 green bits. And what I've done there is they add up to 32, and I'm doing a union of that struct with a variable. It's going to be called raw. And raw is a 32-bit variable, and it shares the same space in memory as there. So you can access white, blue, red or green, or you can hit the whole lot in one go using the raw. And then I create a buffer of that structure, and it contains the maximum number of LEDs, so it's a buffer that's 162 long. So that's what's in the config file. So that's everything I need to know about the hardware and the LEDs. So we go back to the main file. On the main file there's two things we want to do. We want to start a task running, which is the LED task, and we want to configure the I/O. Now in the I/O on the ESP8266 running the RTOS system, we have a thing called GPIO config. And so basically the first thing we do is we create a structure that's a GPIO underscore config underscore type T, and I call it IO underscore conf. And in there's a pin mask, and the pin mask is the pin that you're going to control. So up here, this LED data pin, as you saw before, was set so that it's controlling pin 13, and so we bring it down into here, and effectively we're saying we are going to control pin 13. And then the mode, GPIO mode output, which is all in GPIO.h, which tells you where these are, what these values are. GPIO pull up disabled, GPIO pull down disabled, and the GPIO interrupt disabled. So basically we've just gone for defaults of it's an output and it's on pin 13, and then you pass that to the GPIO underscore config routine, and that sets the port for you. And then the last thing I want to do is we create a task called LED task. We give it a name of LED underscore task. It has 496 bytes of stack available for it. We're not passing anything to it. We're giving it a priority of 15, so quite a high priority, but there's no other tasks at the moment, so it doesn't really matter. And we're passing a variable that the task handle can be put into it, so we can refer to it then outside of the task. So that's just main. And then we jump over to the LED display.c, and if we go to the bottom, here is the LED task, and this is the routine that will be called when the task is created. And so basically all it does is it quickly sends to the buffer the value black, which is 0, to both strings, and so all the LEDs will extinguish. And then we have a second delay, just because you can, and then we run the display. And the run display is just a series of commands to run various effects, and we'll show you that in a bit. So we move on to the more meat of the program, and we come up and we have send LED data. Now this is past the address of the buffer and the length of the buffer, which is what we need to know. And then we enter a critical part of the task. Now this locks the task management system so that we won't get shifted out until we exit the critical stage. And so we're going to loop around, and we're going to start at 0, and we're going to go up until the length is -1. Well, the length is 162 because there's 162 LEDs, but of course we're starting at 0, so we only want 161. We have a mask, and it's 32 bits wide, and it's got the most significant bit set. And then we have a byte, 32-bit byte, where we take the raw data from the first location in the buffer and we process it. And then basically, while the mask is positive, i.e. there's a number in, it's not 0, we AND the mask and the byte, and that becomes true or false. If it's true, we run the routine send _ws_1. If it's false, i.e. a 0, we run send _ws_0. And then we increment, we don't increment the mask, we right shift the mask, so the 8 will effectively become an 040000, and it goes around again. And so effectively it's shifting serially the 32 bits of data that were in that byte. And then when it's done, it goes around, takes in the second byte, shifts that out. At the very end of it, it sets the LED pin low. And so basically there is this function called GPIO _reg_write, and we pass it a GPIO _out _w1tc _address, and that's basically clearing. That's a command to clear the pin that is passed in this data here. Then we delay for 10 milliseconds, and at the end of that delay the LEDs will light. And here, this is the send _ws_0. It's called WS because this bit of code was written for the WS2812Bs, and I've not changed it. I just tweaked these numbers a little bit. Now these numbers is how many loops in the high state and how many loops in the low state we will do. So we come down here, and this is for a 0. So the 0 has a short high pulse followed by a long low pulse. And so we loop around here twice, and we're basically writing out a high, because this is GPIO underscore out underscore W1TS for set, S is for set, C is for clear, and the address, and then the pin data, i.e. pin 13. Goes around there twice, drops through, and then here it goes around 7 times, and here we're sending out a GPIO underscore W1TC, which is the clear and the address and the data pin. So that sends a high for 2 loops and a low for 7 loops. Then we have a send underscore WS underscore 1, and this has got different numbers. Basically it's got its high for longer and its low for shorter, and it's exactly the same. This time we go round setting it up high for 5 loops, and then we drop through and we set it low for 3 loops, and that's basically how I bit bang the ones and noughts out to the string. And that's the main meat of the program. The rest of it is just how we manipulate the string to send out to the LEDs. Right, we'll move on and we'll have a look at LED string effects. And this is basically just a way of manipulating the buffer. All I do is I manipulate the buffer, and at the end of it I fire the buffer out to the LEDs using the LED display routine. And so like here we've got a light quickly routine. It takes a string, so I know what string it is, whether it's both string 1 or string 2. It brings in the address of the buffer to work on, and it takes in a colour, and it's a 32-bit colour structure. Right, so we have an index which is declared, and say we're doing both, because that's easy. Both, we have a for next loop that basically says we start at the start of string 1, we keep going until we're less than or equal to the end of string 2, and we increment it. We take the buffer, we index into the buffer, and we're using the raw bar, so that's a 32-bit value, and we're just making it equal to the 32-bit color that came in. And if it's string 1, then we just do the start string 1 until the end of string 1. And same with string 2, it's the start of string 2 to the end of string 2. And so that's how it does it. And at the very end you see here, send LED, buffer, max string LEDs. So that's a buffer with 162 LEDs data in, and the count and the string length of 162. Slow light is exactly the same. We have a string to know which string we're going to point to. We have a buffer to the LED buffer. We have a color. We have a speed, and we have a direction, because the other one just goes from the bottom up, the quick one, because you don't really care how top or bottom, because it's going up fast, so it just appears. Whereas here we're going slowly, so if we're going slowly you'll see it move, and so we want to know whether we want it to come from the top or come from the bottom. And so basically if we do like string 1, then there is a problem. I think I found a problem. Yep, I found a problem. I shall fix that later, because you can see for case both, if the direction is up we do upwards way, and if it else we go downwards. You know, one's got a positive index and one's got a negative index, whereas the case for string 1 and string 2 is only positive. I've missed out on this one, the direction. So while I'm here I'm going to make a note. Right, make a note of that, so that I can come back and fix that. Fancy not noticing that. And I always have a default at the end with a break, which just does nothing. And as you can see here, each one of these has a send data. So as soon as it's filled, it indexes into the buffer, uses the raw value to put the color in. It then indexes it again, puts the color in, sends the data, delays, and goes around again. And the delay is speed, so that's the bit that come in. I think there's something not so happy with this. I'm going to have to look at this again. This one is a fader, and so basically you pass in the buffer, you pass in the starting point of the LED, you pass in the number of LEDs to fade, and the amount it will fade by. So if you can fade one LED at a time, or you can fade 6 or 7 or 8, or the whole string. And it does the fading by right shifting by 8 each time it's called while it does this. And it's sort of like, I've not got my head around exactly how it works, because I pinched this routine from somewhere off the internet. But the advantage is it's shifting and not rotating. So whatever number is in the red will eventually become 0. And if it comes 0 before the loops stop, it won't go negative or anything like that, because it's just bringing in naught zeros from the left hand side. So when it's gone through the 32 bits, they'll all be 0, which is black. And so you haven't got to worry about, negative numbers and things. And then I'm not going to go through these, just in case I've made more mistakes. Now this one is a color swipe middle out. So this one, you send in the array, you send in which string you want to use to, you want to send in the color and the speed at how fast it writes. And so basically you've got a string of already set to one color, and this will go into the center and it will put the new color in and work out from the center, so it wipes out from the end. And then of course the speed is how long it delays before it goes around and does it again. And so very much the same for string 1, string 2 and both. And then there's one that's the color swipe ends in. So same as that, but instead of starting at the middle, it starts at the ends and works into the center. So I can move up slowly, so if you want to look at it you can, and come back with any mistakes I've made. And then this one down here is my comet, and at the moment I only have the comet going up, but I have an array for comet up and comet down, because obviously when it's going up I want a nice bright white at the top and then dulling down to orange as it goes up and as the tail comes down. And if it's coming down, I want a nice bright front half coming down and then it dimming to orange at the top. So it's just the array swap round. And I thought by having 2 arrays, it just meant I don't have to go backwards or forwards through the array. I can just have an array for up and an array for down. And then I've got a head position and the size of the comet. Now they will have to be taken out because they're magic numbers and they need to be converted to understandable English. So like instead of being comet size, it will be like user comet size or something like that. And then we have a case for both, if it's going up both of them, and a case for string 1. And so this uses the fade command, because as it's going up it's fading the one below the white out more, so they flicker out a bit more. You'll see that when it's running. The display will be running while I'm talking, and it'll be probably running up in the top right corner. And that's, oh no, one more, changing hue. And this one allows you to change the hue of the strings, and that's basically using some software or some code that I pinched off the internet. And you see here I found it at GitHub, and there's a name, CIEMBOR, and I've borrowed his code because it does everything I want, and it saves me having to work out exactly what it is. I just use it much better. And the same with the colours. I did hunt around and I found a location where there was an array of colour names and 32-bit values for them. Well, all I had to do was take their data and then swap all the sort of bytes around in here, because I think they were for RGB, and then I got RGBW, which is why you see a lot of zeros, because that's where the white one is. And the order of LEDs is different. The order of these LEDs is different to the WS2812s, and it's different from the data sheet. Even the data sheet gets it wrong. Just a quick one here for the data sheet. You can see here on the data sheet it definitely says it's R7 to R6 etc. down to W0, and so the data structure according to this is red, green, blue, white. If you look at the structure here, it is definitely green, red, blue, white. So even if I was switching the wrong way, so it will be green, red, blue, white, you know, it's the fact that the two colours, green and red, are swapped over. Red is next to blue, whereas here on the PDF here, red is definitely next to green. So the data sheet is wrong, or I've got the wrong data sheet, but it definitely the data sheet that shows up for SK6812's RGBWs, but obviously this company make them different. So the problems you have with hardware, and if I remember I'll pull that up. And so there's all the colours. You can see red has just got the 8 bits where the red LED lives set to FF, and there's our RGB white, which has just got red, green and blue set to FF and the white set to 0. And then down here somewhere there'll be a white, and that's got all the RGB values off and the white LED at full brightness. So quite simple to do. And so that's basically it. The last one is this run display, and this is just a whole load of different effects that are in the string effects, and just used so you can see them going on. So you would have seen the comet on string 1 going on string 2 and then on both, and you'd have seen what the slow light looks like. That's mainly just playing around with the slow light and the quick light to turn it all to red. And then there's ones here where we're doing a fade. We're setting it to a colour, doing a fade. Oh, set it to red, doing a fade. Setting it to green, doing a fade. Then to blue, doing a fade. And then we got here 3 string colour swipes in from each end. So basically starting with green and sweeping the blue, and then starting with green and sweeping the blue again. So what we got here, this is string 1. Oh, we're doing string 1, string 2 and both. And again here 3 string colour swipe out from the middle, and we're doing string 1, string and both. 3 string colour hue changes, so changing from one hue to another. And then we got here green, blue to mid, and then red out. So I'll just go down there so you can have a look at that. It's basically just doing a sort of swipe in, swipe out, and then at the end a quick light, setting them both to black to turn them off. And that's about it. So hopefully you've seen how I've gone about just making this software. And of course it's not as good as WLED, but this is from how you can start from scratch and build your own. So hopefully that'll encourage people to do something other than just load WLED. But you know, there will be a video in this series with this light running WLED, because I do like how it works. And you know, this is me spending quite a few hours over a few days to get it to work. And WLED, you just download it and it runs. But I like to know how it works, how to do it, and I just find it interesting to write my own displays. If I was 20 people, this would have been a lot quicker and a lot better. So if you like what you see, hit subscribe. Doesn't cost nothing. It's free to do. Hit the notification bell so you know when I'm posting the next video, and then click on the like if you did like it. And please comment. You know, I don't like just doing these videos and chucking them out. I like people to come back and say whether it's rubbish or whether it's good, or what bits they liked, which bit they didn't like. You know, and of course, comments get me noticed, likes get me noticed, subscribers definitely get me noticed. So please subscribe, costs nothing. Like I say, hit the like button, and I'll catch you on the next one.